Hey guys, welcome to another edition of Morrow Teaches Online. We actually have a special edition today. It's Regions Review time. And right now we're going to be talking about June 2024's Regions, questions number 13 to 24. So, if you would like to pause the screen right now so you can check your answers, please do that right now. Again, we are going to be looking at questions 13 to 24. So that would be these answers. And again, see how you did out of 24. If you got 15 out of 24, congrats, you would have passed June 2024 regions. And let's see if we got anybody out there who actually won 24 out of 24. Because now we're in the possible running for 100. So again, you can pause the screen so you can check all your answers. And if not, here we go. Okay. So, number 13 starts off with a pretty easy question. It says the box plot below summarizes the data for the amount of snowfall in inches during the winter of 2021 for 12 locations in western New York. And here comes the most important part. What is the interquartile range? Okay, so as you can see, I love it when people label it. So it's min, Q1, Q2, Q3, and max. And we call Q2 usually the median. Well, if you look at the formula sheet, which is right here, ta-da, you can even see, if you forgot what interquartile range means, whoops, it literally says, it's just, oh my goodness, I hate when it does this. You good? Okay. You can see right here, it says IQR is Q3 minus Q1. So even if you forgot what interquartile range is, the formula sheet's got you covered. So if you go back to number 13, it's just Q3 minus Q1, like we have written right here. So let's see, we already labeled it. Q3 is 110, and Q1 is 60. And then you just do 110 minus 60 is 50. And that's an easy answer. So that one, I'm sorry guys, you gotta get right. Too easy. Okay, number 14. So for number 14, it says 4 quadratic functions are represented below. Then the follow-up is, which function has the smallest minimum value? Okay, so why don't I start with the most obvious ones? So remember, minimum is the lowest point. We'll write that out. Lowest point. Okay, so let's start with the graph. I think we can all clearly see that the lowest point is at -4. Okay, so that's one of them. Now let's look at the table. I like to play something called the friends game, or some kids call it the rainbow. Do you see how -1 matches -1? So those guys are friends. -4 matches -4. Those guys are friends. Did you see how -5 didn't have any friends? That's because he's the vertex. And remember, another name for the vertex is the minimum. So the minimum is at -2, -5, which again, you just take the y value. So this guy had a minimum at -5. So far, 4 is winning because -5 is smaller than -4. Okay. Also, if I sound exhausted, it's because it's right now 3:40 in the morning. So here we go. For 14A, I'm sorry, the first one. Here we go. You have two options. Since it's written in vertex form, you can just do the trick, okay, which stands for opposite keep. So you get opposite of -3 is 3, keep the -7. So there's your y value. It's at -7. So he's definitely winning at the moment. For 3, also going back to that first one, you could always just graph it and then see what it is. But if you remember the OK trick, it goes much faster. So number 3, you can't do the OK trick because it's not in vertex form. So obviously, if you see an equation, I would definitely graph it. Okay, let's see if this works. Okay, so go to the graph, you type in x squared. What was it? I already forgot. Silly Morrow. 6x plus 3. Okay. Okay, man. X squared plus 6x plus 3. Okay, now your go-to button is menu, trace, graph trace. How will we know when we get to the minimum? Because it will literally yell at us, there's a minimum. Ta-da! So our minimum is at -3, -6. So let's write that down, -3, -6. Okay, and there it is, it's at -6. So who was the smallest? -7 is the winner. So it must be choice number 1. Okay, again, does it take a little time to figure out? Yes, but guess what? On the regions, when you have 3 hours, time is something you have. Okay, number 15 says the equation represents a sequence. The second you see that word sequence, you know it's either arithmetic, mind my handwriting, or geometric. It's got to be one of those two. So the first thing you got to decide is, are we looking at an arithmetic sequence or a geometric sequence? Well, remember, arithmetic starts with an A, so does adding. So if you have to add or subtract, it's arithmetic. If you have to multiply or divide, it's geometric. So how do we get from -2 to -5? Well, you -3. Well, how do you get from -5 to -8? -3. -8 to -11, -3. And if you really, really wanted to know, from -11 to -14 is also -3. So since we're subtracting, that tells us it's got to be arithmetic. So remember, go to the formula page anytime you need a formula. Most of them are there. So if we go to the formula page, it's got so many goodies. Let's see if this doesn't glitch this time. We know it's an arithmetic sequence. So we know we're using this formula right here. Okay? So it doesn't give you the formula, so you would have to know, okay, I got to look at the formula page and then look for which kind of sequence is it. It's arithmetic, so use that formula. So here's the formula again, right from the page. Okay, so what's the formula? A sub 1 means the first number in the sequence. Well, the first number in the sequence is -2. So let's start getting rid of some. That does not say -2. That does not say -2. This guy does, and so does this guy. Okay, we're already down to 2 choices. Then the D stands for common difference. Well, the common difference is what are you changing by each time? It's -3. So this guy's got -3. That guy has a +3. And there's your winner. Here's what you could always do if you really want to make sure you got it right. If you go to the calculator, here we go. We type in, let's delete this. We type in -2 plus -3. We're typing each answer exactly as we see it. Let's type in the actual answer though. Instead of n-1, type in x-1. If you go to the table now, you can clearly see -2, -5, -8, -11, -14. That's the sequence we just had. So we know we're right because it gave you the same exact numbers. So there's your winner, okay? They haven't been asking it lately, but in the olden days of like 6 years ago, they used to make you distribute and then combine like terms. They haven't been making you do that lately, but if you don't see this as a choice, it's probably because they simplified it. So just be careful with that. Okay, number 16. So 16 is a dot plot. They've been asking a lot of dot plots lately. And they're asking which statement about the dot plot is correct. So you could do this all by hand. Again, the mode is the one that's going to have the most dots. Why is it changing? So clearly 3 is the mode because the most dots are at 3. So why don't we write that? Mode is 3, so anywhere I see the word mode, I'm going to write a 3. Now mean is annoying because you're going to have to add it all up, zeros, there's 3 zeros, 3 ones, 4 twos, and so on. But guys, anytime it asks for mean or median, I would use your spreadsheet. So let's do that. Oops. It's not the easiest to work on this. Okay. So remember how to get to the spreadsheet. You press on, which is the home button. You go to the button that looks like a waffle. We have to give it a name. Let's give it X. Okay, so now we're going to type in all the dots. So there were 3 zeros. 1, 2, 3. Okay, what else we got? We got 3 1s, 4 2s. Let's keep that going. 3 1s, 4 2s. What does it do? 3 1s. 1, 2, 3, 4 2s. 1, 2, 3, 4. What else we got? We got 5 3s, 2 4s, 2 5s, and 1 6. Okay, let's see if I can remember that. I'm not getting that old. Okay, we got 3 5s. 1, 2, 3, 4, 5. 2 4s. 1, 2, 2 5s. 1, 2, and 1 6. Okay, so it says I have 20 numbers, which is, I believe, how many dots there are. So remember, if you want to find mean and median, the code is 4, 1, 1. Okay. X is the X list, and that's all we need. So we got to go all the way back to the top. And remember, the X with the line on top, that's your mean. So it's telling you the mean will be 2.5. So we wrote 2.5. Okay, now we go back. The median, it will literally say the word median. Median is also 2.5. So that's why we wrote 2.5. And like we said before, the mode is 3. So which one is true then? Okay, mean is 2.5. So everywhere I see the word mean, I'm going to put 2.5. I'm sorry for the messy handwriting. Median is also 2.5. So which one is correct? It's got to be this one, because 2.5 is equal to 2.5. And we got a winner. Okay, 17. You got a few options. You can either memorize all the tricks, and we're pretty good with the tricks. How did this equation become that equation? So you can see how there's now a -3, there's now a 2. So what are the tricks? Where do you see the -3? Inside or outside? It's inside. Minus has 5 letters. So does the word right. So remember, if it's minus inside, it's right. If it's minus outside, it's down. So we know it's going to go right 3. So we're down to these 2 choices already. And remember, the bigger the number in front. So anytime the A or the number in front is bigger than 1, the more narrow it gets. And there's your winner. Now, if you don't remember the tricks, guess what? You can always graph it. Now, remember, we always ask, how do we get from f of x to g of x? So like they wrote over here, f of x should be your first equation. G of x should be your second equation. So let's type this in. If this thing would stop glitching again. Okay, let's delete this. Control W deletes that. Okay, so the first graph, x squared. What do you know? A beautiful U. How do we add a graph? Tab, and now we type in the second one. So let's see how it changed. 2x minus 3 squared. You can see how it moved right 3. The red one moved right 3, and it got skinnier, and the word for skinnier in math is narrower. So you got a few options for that guy. Okay, let's go to 18. 18, it says on a Saturday, Dave took a long bike ride. How intriguing. The graph below models his trip. Beautiful trip. So it's about miles traveled and hours. It says, what was Dave's average rate of change? They love this kind of question on the regions. Average rate of change. Well, rate of change. The trick for rate of change is rock. Where do you find rocks? On mountains. Mountains have slopes. So this is just a fancy way of saying do slope. Now, you got a few options for slope. So first thing you could do is you could use the formula sheet and use the actual slope formula. Y2 minus y1 over x2 minus x1. You could do stacking. So we could just take the 2 points and just stack them on top of each other. We could do rise over run since we have a picture of a graph. Or you could actually use the spreadsheet and type in both points and do 4, 1, 3, and whatever the m is, that would be your slope. So I'm actually going to do rise over run. Now, you always ask, well, how do I know which points to use? They would tell you, oh, yeah, use hour 1 and hour 3 if they wanted you to use hour 1 and hour 3. If they just write on this trip, they're talking about the whole trip. So that means the starting point, which is 0, 0, and the ending point, which is 5.5, comma 60. Sorry, comma 55. Whoopsie. So I'm just going to do rise over run. So we're going to rise 55, and we're going to run 5.5. And then remember, the expression is rise over run. So that's what we wrote right here. I don't know why they're putting the zeros. That's a little weird. Oh, I got it. I'm sorry. I thought they were writing decimal zeros. It's -0. So they're doing the slope formula. Honestly, I would just do rise over run. So just do 55 over 5.5. And what do you know? You get a slope of 10. And there's your winner. Okay, number 19. There's a real way of doing it, and then there's the Morrow way of doing it. So the real way is, remember, if you see two bubbles next to each other, that's just FOIL or box method. So if you forget how to do it, x times 2x is 2x squared. X times 7 is 7x. -2 times 2x is -10x. And -5 times, I was supposed to pick a different color. Come on, Morrow. -5 times 7 is -35. Okay? But now you take this. Okay, we combine like terms. 7x minus 10x is -3x. But now they want you to subtract that x plus 5. So then you got to distribute that. So when you distribute it, you get -x. And you get -5, and then you combine like terms between that. I'm going to be honest, that is just begging for a mistake to happen. So here comes the easy way of doing it. Whenever you see the word equivalent, or you see expressions or equations, I would just graph this. So let's do it. Okay, so Doc B, let's graph the whole question. Again, let's pretend I actually remember what it said. X minus 7, parentheses, 2x. I want to say it's plus 5, but who knows? Plus 7. Good job, Morrow. So this was completely wrong. Silly Morrow. So 2x plus 7. And then I believe it was minus x minus 5, but once again, I'm old. And I bet it's plus 5. It is plus 5. Good job again. Oy, oy, oy. Okay, so we graph this. Hopefully it's correct. Should I check one more time? Okay, cool. Okay, back to the graph. It makes this beautiful picture. All we got to check now is which one matches. So press tab. Let's start typing them in. To save time, let's just type in the real answer. 2x squared minus 4x minus 40. Here we go. 2x squared minus 4x minus 40. If this really is the answer, it should make the exact same picture. What do you know? It does. And how many times has this kind of question come up already on this one Regents test? The more you graph, the easier this test gets. That's the trick. Okay, number 20. They give you two functions, f of x and g of x. And again, this comes up a lot on the Regents too. When does f of x equal g of x? That's just a fancy name of saying, where do they intersect? So they intersect here, and they intersect there. Again, there's not really a trick for this, because the trick is just do it the real way. Now, what they should have written was, write all the values of x where f of x equals g of x. Clearly, they didn't write that. But you have no choice but to take the x's, because you don't have a choice of points. So let's see where they intersect. They intersect at 5, 5, and they intersect at 1, -3. All we care about, though, is the x value. So we care about 5, and we care about 1. So The winner is, he never picked answers. Silly. There's your answer. 1 and 5. That was a very easy question if you know what this means. Okay. Number 21. We're almost there. When babysitting, Nicole charges an hourly rate and an additional charge for guests. She uses the function C of H equals 6H plus 5 to determine how much to charge for babysitting, because this is obviously what babysitters say when they're asking for money. The constant term, that's the big CO word. The constant term of this function represents what? So let's remember what each thing is. The 6 is called a coefficient. That is not what we're looking for. Wrong CO word. The H is a variable. Again, not what we're looking for. But the 5 by itself, because it has no letter next to it, is called the constant. So they're talking about the 5. They're basically saying, what does the 5 mean? So let's go back to the question. It says she charges an hourly rate. Anytime you see that LY, hourly, or per hour, or each hour, or every hour, they're talking about what's next to the H. So 6 is the hourly rate, but that doesn't tell me what the 5 is. So 5 must be the additional. That's why they use a plus. The additional charge for gas. And that must be what the $5 is somehow we're paying this babysitter for the gas. I don't know about you, but there's no way I'm paying my babysitter for gas. You're already paying me and charging enough for those hours. So again, additional charge for gas is the answer. I don't really have a trick for this because you just kind of have to know it. Okay, 22. Welcome to the hardest multiple choice question on this whole Regents. When this was given to my students, it was not pretty because there is no trick for it. You just got to do it the real way. So we're going to do this one from scratch and just hope we understand it. So 3x minus 7 is equal to ax plus 5. And it says when solved for x in terms of a, meaning a should be in your answer, and we're solving for x, meaning x needs to be by itself. Now, not only are these questions tough, but look at what our question is. It has 2 x's. That makes this so much harder than it needed to be. But here we go. Are we ready? So first thing we want to do is get all the x's to one side. So let's do that. So let's move the ax to this side. So if you're adding ax, we need to subtract ax. Okay, so when we do that, goodbye ax is on that side. You get 3x minus ax is equal to, nope, I forgot the minus 7. And what it is, I'm so used to doing it all at once. Silly Morrow. Okay, now we got the rest of it. Minus 7, that came from here, equals 5. Okay, now we want to move the numbers to the other side. So let's do that. Add the 7 to this side, and you get 3x minus ax is equal to 7 plus 5 is 12. So most students could get up to this part, but then they were like, how do I get the x by itself? There's 2 of them. So here's what you got to do. You got to factor out an x. And I know you're like, oh my goodness, we haven't used that word in forever. Well, you got to do it. So do you see how they both have an x? We got to basically pull an x out of each. We're going to take an x out of this guy. We're going to take an x out of that guy. So when you take an x out, what are we left with? We're left with just 3 minus, we're left with just a. Okay? And again, if you don't believe me, what could you always do to check it? You can always distribute the x back in, and you would see that you get back to there. Okay, so we got this on the left, and we got 12 on the right. We're almost done. How do we get x isolated by itself? Well, what's next to x? This 3 minus a. So if you're multiplying by 3 minus a, You got to divide by 3 minus a. That gets rid of this. And what do you know? We get an answer of x equals 12 over 3 minus a. This is a very tough question. I want to say 1/3 of all the students got it right. So if you got it, give yourself a pat on the back because I'm impressed. Okay, we got 2 more questions. 23. I don't have a trick for it. The trick is doing it the real way, but it's not a hard question if you remember how to do these. So what they want is they want the final answer in miles per hour. So remember how this game works. If you see it on top and you see it on the bottom, you can cross it off. Well, I already know it can't be number 1 because it says meters on top and it says meters on top too. They both can't be on top. One has to be on top, one has to be on the bottom. So since they're both on top, that cannot be your answer. So let's look at number 2. Meters on top, meters on the bottom. So far, so good. But I got seconds on the bottom and seconds on the bottom. That's no good. You can't have 2 seconds on the bottom. So that can't be it. So choice 3 is going to be the answer. And let's see why. Meters on top, meters on the bottom. That crosses off. Seconds on the bottom, seconds on top. That crosses off. We're left with miles on top, hours on the bottom. And that's what we wanted. We wanted the final answer in miles per hour. And the reason why 4 is not the answer, again, you can't have 2 meters on top. So that can't be it. And the final multiple choice question. Which function has a domain of all real numbers and a range greater than or equal to 3? Okay, so first thing is, obviously, if I see all these equations, I would graph it. To save a little time, I'm just going to graph it right here. Number 1 looks like this. Number 2 looks like this. Number 3 looks like this. And number 4 looks like this. Again, sorry for the awful drawings. Here's the first thing. We're looking for a domain of all real numbers. Here's the funny part. They all have a domain of all real numbers because they all go on forever in both directions. So that didn't help me one bit because they all work. So now all we're really looking for is which one has a range. Remember, range is your y, domain is your x. So which one has a range of 3 or more? So we're looking for y is greater than or equal to 3 range. So I would graph it. Let's start with the first one. Negative x plus 3. So let's delete this. Negative x plus 3. So do you see how it goes all the way to the top and all the way to the bottom? That's going to go on forever. So its range is also all real numbers because it never stops. It just goes all the way to infinity and it goes all the way down to negative infinity. So that can't be our answer. Okay. Should we save the last one as the answer? Oh my goodness. Okay, so it can't be this guy. Let's try choice number 3. 3 to the x. So again, 3 and then caret button to the x. Remember, this is the one where there's an asymptote somewhere. Well, if you notice, it looks like it's touching the the x-axis, but it's never actually going to touch it. But the range for this guy, do you see how it never gets below 0? So the range would be y is greater than 0. So that can't be the answer. We're looking for y is greater than or equal to 3. So now let's look at choice 4. Choice 4 is absolute value of x plus 3. Now, remember the x plus, first of all, absolute value, you go to the Walmart button, which got everything you need. So x plus 3 inside. Do you see how the lowest this graph ever gets is 0 also? We're looking for at lowest being 3. So that can't be it. And the final one, x squared plus 3. So here we go. Oh my goodness. Come on. X squared plus 3. And you can see how it never gets lower than 3 and it's above 3. And if you don't believe me, let's use menu, trace, graph trace. And you can see how its minimum or y-intercept is at 3, and it never got lower than that point. So we got a winner. It's this one. So I hope you liked the video. I hope this helped. I wish you the best of luck on part 2s, 3s, and 4s, and let's hope we got a good regions grade. Until next time, bye guys.